Let's take a look at this first question. They're telling us that we have a communication tower that is 200 meters tall. There are a series of wires that are attached to help this communication tower stay sturdy. We have 4 of these red wires, and they're attached at the top of the tower, and they go down to the bottom, and we're told that the angle of elevation from the bottom up to the top of the tower is 65 degrees. So this angle right here is 65 degrees. Then we're told that we have 4 shorter wires that are attached somewhere up the tower. They make an angle of elevation with the ground of 50 degrees. So I'm going to write that right here. So this angle here is 50 degrees. But we don't know how high up the tower this goes. The question is, if all wires are attached to the ground at the same distance away from the base, so this distance across here, which we'll call y, find the total length of all the wires and include an extra 4 meters to fasten the wires. So basically, we want to find the length of the red wire and the length of the blue wire, and because there's going to be 4 red wires and 4 blue wires, we'll multiply each of those by 4, and then we'll add an extra 4 meters. So let's start with the red wire and see if we can figure out how long this red wire is. We're just looking at the triangle that has the green line off to the left hand side, the hypotenuse is the red wire, and then the ground. The information we're given is that the angle down here is 65 degrees, so that makes this side the opposite, and that makes this side the adjacent, and we're trying to find the hypotenuse. So we don't really need to know y right now. We can figure out h by using our sine function, because sine of theta equals opposite over hypotenuse, and we know that theta is 65 degrees for the longer wire, and we know that the height of the tower, which is the opposite side, is 200, and we just need to find out the length of the wire, which is h. I'm going to move the h up to this side over here, and I'll move sine of 65 down to the bottom on the other side. So I end up getting h equals 200 over sine of 65. And when I pull my calculator out, I get a distance of 220.7 meters. Okay, so that's how long one of the red wires are, or one of the long wires are, and there's 4 of these, so later on we're going to have to multiply this by 4. Okay, now let's take a look at the blue wires. Now the blue wires, if we take a look at this triangle, we don't know this distance, we don't know how long the blue wire is, and we don't know this distance. And to be able to use our prime trig ratios, we need to have some more information. If we go back to the triangle that has a hypotenuse represented by the red line, we could actually use that to calculate y. And once we know what y is, then we can start focusing on the small triangle. So let's do that. So we know the opposite, we know 65 degrees. So in the big triangle, we can calculate y using our tangent function. So we're going to end up getting tan of theta equals opposite over adjacent. We know that theta for the large triangle is 65, and we know that the opposite is 200. And now we can find the distance along the ground where all the wires are attached by calculating y. Move y up to that side, and tangent of 65 comes down to the bottom on the right side. We end up getting y equals 200 over tan of 65, which equals 93.3. So now we know the distance from the base of the tower out to where all the wires are attached is 93.3 meters. And that's going to help us solve for this value right here, which we'll represent by a z. Okay, in the smaller triangle, the one with the blue hypotenuse, we know that the angle here is 50 degrees, which makes this side over here the opposite, the adjacent, which we just calculated as 93.3, and then the hypotenuse is z, which we're actually trying to find. Okay, so if we're trying to find z, which is the hypotenuse, and we know the adjacent, we are going to use cosine. So we get cosine of theta equals adjacent over hypotenuse. We know that in the small triangle, theta equals 50 degrees. The adjacent side we just calculated, and we know that that's 93.3. And the hypotenuse is the length of the shorter wire that's attached halfway up or part way up the tower. And we represented that by z. So Cross multiplying to move the z up to that side on the left hand side and the cosine of 50 down to the bottom, we end up getting z equals 93 divided by cosine of 50, and we end up getting z equaling 145.1 meters. So now we know the wire represented by the blue line is 141.1 meters long. We also know that the wire represented by the red line is 220.7, and we know we have 4 of each of those. We can calculate all the wire that is necessary. So we are going to take our 145.1, we're going to multiply that by 4, and we're going to take our 220.7 and we're going to multiply that by 4 as well. And then after we find out an answer to both of these, then we're going to add 4 more meters. Let's see what we get. So after I did my calculations, I found out for the shorter wires we need 580.4 meters of wire altogether. For the longer wires we needed 882.8 meters of wire altogether. When we added that up together, we got 1463.2, added 4 meters to that, and altogether we are going to need 1,467.2 meters of wire. Whew, that was a long one. Let's take a quick look at the questions that you're going to be doing for homework. We have somebody named Joanne who is flying a kite, and she's going to let out 228 meters of kite string. And she's estimating that the angle of elevation is 45 degrees. And she wants to find out how high above the ground the kite is. In this next question, we have a tree, and it casts a shadow that is 38.5 meters long, and it says that the angle of elevation of the sun is 54 degrees, and you're asked to determine the height of the tree. So you want to figure out what x is over here, given the information in the diagram. Alright, this question looks fun. We have 2 buildings, 1, 2, and it tells us that they're 14.7 meters apart. So that's probably this distance down here, 14.7 meters. It also tells us that the angle of depression to the top and the bottom of the second building, so we're looking from up here down to the top and to the bottom of the second building, and it's telling us that the angles of depression are 27 and 64 degrees respectively. And it is your job to determine how tall each of these buildings are. Now let's represent that by X and Y. Good luck.